Hey guys, I wanted to talk a little bit about atoms today and the octet rule. So first of all, what's an octet? An octet is a group of 8 things, just like a duet is 2 things, a quartet is 4 things, maybe musicians, maybe objects. And in chemistry, the octet that we're talking about is electrons. So 8 electrons is kind of a group size that makes atoms stable. So the octet rule says atoms are most stable if they have 8 electrons in the outer shell. So we can show that in a couple different ways. There's Bohr models, which is what you see here, and Lewis structures or Lewis models that you see here. Electron dot diagrams, they're also called. And we'll talk about the differences between those. So first of all, looking at the Bohr models, Bohr model is going to show all the electrons that an atom has, starting with the inner shell that only has 2, so that's one exception to the rule. Hydrogen and helium follow the duet rule. They only have 2 electrons in their outer shell, and if they get 2, helium is really stable, it's happy. Right? We all a lot of times talk about atoms being happy and wanting electrons, but it's really just stability. And then you add more electrons, go into lithium, beryllium, till you get to neon that has 8 in its outer shell. So over here, the noble gases, they all have full outer shells. They're all stable. And then so you can see argon, the 18th element, the last one shown on this small table, has 2 on the inner, 8 on the second, and 8 on the third, and you can see all of them here. If you look at the Lewis structure, argon only has 8 because Lewis structures only show the outermost shell or the valence electrons. So that's what we call the outer shell, is the valence electron shell. And those are really helpful when you want to show bonding relationships. Okay, so when you're making a Lewis structure, something important to know is you want to keep electrons single. Like if you look at carbon here, it's got a single, 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 single. You put electrons on the top, the bottom, the left, and the right of the symbol, one at a time, and then you double them up once you get to 5. So nitrogen has a pair here doubled, oxygen has another pair doubled, fluorine another pair doubled, neon has 4 pairs all around it. And then you start over again with sodium with just a single. And then 2, 3, 4, 5, 6, 7, 8. So why does that matter? If you look at elements on the left side of the table, like lithium, sodium, magnesium, metals, they all have a low number of electrons. 1, 2, 3. So basically, the best thing they can do is just get rid of those, right? If you look at the Bohr model, if lithium gets rid of this 1 electron, then it has these become the outer shell, the 2 underneath, and it's a full shell. If sodium gets rid of this 1 electron, it has these 8 underneath now become the outer shell, and it's a full outer shell. So the metals, get rid of them. If you look at the right side of the table, chlorine, fluorine, oxygen, they have higher numbers, 6, 7, 7, so they want to just add a couple. Oxygen has 2 little holes here, or if you look at this one, it's got 2 singles that want a pair. Fluorine has 1 single that wants a pair, so it's trying to add electrons. And that's going to be really important when we talk about bonding and sharing and transferring electrons in ionic and covalent bonds in the next couple weeks. So hopefully that helped you understand a little bit about how electrons pair and join up until they get to 8 to meet the octet rule.